Hello, this is the regression data analysis project for marijuana. My name is Xander Wiersham.
I'm Graham Gonzalez.
I'm Moriat Lurie.
I'm Hannah Pinkerton.
And I'm Kristen Knight.
So a little bit of background on how we came to the conclusion of this topic for our statistical analysis. Throughout our lifetimes, there has been a dramatic shift in the narrative. Throughout the 20th century, it was a war on drugs narrative compared to now a medical cannabis world that we live in the 21st century. Leagues such as the MLB, NBA, and NFL have all relaxed consequences and testing on cannabis. They see it as a medical treatment now rather than as an addiction. Some factors of the study that our group determined, which we will go in later slides, is that we are going to determine that first use of marijuana, the age of first use of marijuana from the age of first cigarette use, the age of first hallucinogen use, and the number of days skipped work in the last 30 days. So how was this data obtained? It was a national survey on drug use and health. The principal investigators were the U.S. Department of Health and Human Services, the Substance Abuse and Mental Health Services Administration, the Center for Behavioral Health Statistics and Quality. Now, these studies, there was no foul play. The collection appears to not break any statistics rules, so we're confident in the numbers that were provided. Now I'm going to hand it over to Graham to talk a little bit about the methods that we had during this project.
Yeah, thanks, Xander. So arriving to the model, we originally had 16 variables that we wanted to look at for various different reasons, and we used reg subsets to make a parsimonious model to look at which variables had the most predictive power. And what we found from that was that the age of first using or trying a cigarette and the age of first use of a hallucinogen and days skipped in the last 30 days of work all had the most predictive power. Now, the number of days skipped in the last work was skipped and not from health-related issues, and we made sure to differentiate that. So the methods of cleaning the data were fairly simple. We made a subset of the 4 variables that we wanted to use, and then we used na.omit on that subset so that we ended up with 4,478 observations that all had answers for every single one of our variable columns in that section. So our methods for looking at outliers, we found that there were no considerable outliers when looking at age of first marijuana use. We concluded that there's just a large range of responses from this, and that they were important to our model and to the story of the data in general. The age of first cigarette, we had one outlier found, and that was at age 69. We considered that the variable did not have enough statistical significance to leave out. However, we did end up making a subset that excluded any response above the age of 55 and below the age of 12. And that helped out with the 2 other outliers as well that were in hallucinogens. So yeah. For transformations, in an attempt to help with normality and look at the QQ plot to have a straighter line, we ended up using square root log of x, x squared, and we did the same thing for y. We ended up making over 134 different subsets and combinations for this model, and none of them proved to have enough change in correlation between each variable and age of first marijuana use. So in looking at that, we found that none of the transformations were helpful and that this was just going to be unruly data that is from the real world and something that we couldn't really help. Next, I'm going to give it over to Kristen to give us some more descriptive statistics over our variables.
Thanks, Graham. For the 4 variables that we looked at in our regression model, we made sure to look at the distribution of all of these variables. So the first variable that we looked at is the response variable, and that is the age of first marijuana use. The mean for this variable is 16.52, and the standard deviation is 4.06. And as you can see, the box plot and the histogram it's provided for this variable, which also shows the distribution. The first predictor variable is age of first cigarette. The mean for this variable is 15.51 and the standard deviation is 3.85. You can see the box plot in the histogram that shows the distribution, and we also have a plot that shows the relationship with the response variable. The second predictor variable is the first use of hallucinogens, the age of the first use, and then the mean for that variable is 18.19 and standard deviation is 3.88. And again, you can see the box plot in the histogram showing the distributions and the plot that shows the relationship with the response variable. And our last predictor variable is the days skipped work in the past 30 days. And the mean for this variable is 0.2 and the standard deviation is 1.05. And again, you can see the histogram and box plot for the distribution and the plot that shows the relationship with the response variable. And next, I'm going to pass it off to Moria for the results.
Our final regression model, we had to calculate the first use of marijuana was 5.852 as the intercept, which had a confidence interval of 5.4 to 6.25 plus 0.253 times the age of first cigarette use plus 0.327 times the first hallucinogen use plus 0.017 of days skipped work in the last 30 days. And the coefficients for both the cigarette use and hallucinogen use were within a range of 0.05 at max. So we determined that it was not like a huge range of difference. And for workplay, it was also a similar range that it was different with. And we ran a prediction with the confidence interval for marijuana age using the first use of cigarette and hallucinogen as 15 and the days missed work in the last 30 days as 15. And we got an age of 14.807 with a range of 13.92 and 15.96. So for our model, we got a multiple R-square of 0.3602 and an adjusted R-square of 0.3597, which essentially means that given the number of variables we have, our model accounts for 35.97% of the variation in our dependent variable of the age of first marijuana use's variation, and the p-value was very low, and it was very low for all of the coefficients other than the days missed work in the last 30 days, which just means that the data wasn't how we expected it to be or wanted it to be because it's real world data and we couldn't really predict that. And even though it was the next best variable given our parsimonious model, it still had a high p-value, so that's just like how it is. And next, Hannah will give our conclusions from this report.
Thank you. So for our conclusions, like Maurice said, the model we created resulted in an adjusted R-squared of about 36%. The model included 3 variables that we believe have the most predictive power. Those 3 variables were age of first cigarette use, age of first hallucinogen use, and days skipped work in the past 30 days. So we found this to be the most efficient model using age of first marijuana use as our response variable. So some of the limitations, the size of this data set was extremely large, so that made it a little bit difficult to manage. We had a lot of missing values, so we had to rule out some missing data and outliers so that wouldn't have affected our results. Another limitation was the variation in some of the survey participant responses, so we had to carefully consider some of the underlying reasons why there was so much variation in the responses. And we came to the conclusion that this was probably due to the fact that some of the participants didn't remember the age of the first time they tried some of the drugs, or they weren't comfortable answering. So overall, this model helped us to predict the age of first marijuana use among those who have used marijuana. And we believe that the model might be useful to do further research on the idea that marijuana is linked to nicotine addiction, because we have age of first cigarette use as one of our predictor variables. Thank you.